A single machine gun, in theory, can stop an entire company advancing across open ground. Point it straight at the attack and it can kill dozens of men before they close the distance. In practice, that same gun often goes silent within the first 2 minutes, and the position falls anyway. The problem usually isn't the weapon, it's the direction it's pointing. And once you understand why, a strange detail from D-Day starts to make sense. Some of the deadliest German gun positions at Omaha Beach were almost impossible to hit from the warships sitting right offshore, not because they were hidden, but because of where their guns actually pointed. Start with something every gunner learns the hard way. Even a machine gun locked onto a tripod, aimed at one fixed point, doesn't put every round through the same hole. The barrel vibrates during automatic fire, no two cartridges burn powder in exactly the same way, and the weapon's own recoil shifts it slightly between shots. All of that scatter adds up into what's called a cone of fire, and where that cone meets the ground, it paints a long, narrow oval called the beaten zone, dense with hits in the center and thinning out toward the edges. Point that gun straight at an advancing line of infantry, and the beaten zone stretches away from you, out into the field, long in the direction the bullets are traveling, but only as wide as a couple of men standing shoulder to shoulder. Most of that oval lands in the gaps between soldiers, not on them. Worse, a gun firing head-on gives itself away instantly. Muzzle flash, dust kicked up by the blast, tracers pointing straight back at the source. Within a minute, mortars and tanks are hunting for exactly one spot, and rifle fire is walking toward the same gap in the wall. A frontal machine gun wins the first 30 seconds and loses the fight. So change the geometry instead of the firepower. Move the same gun to the side of the field and aim it along the enemy's line of advance rather than into the face of it. Now the long axis of that same beaten zone runs down the length of the formation instead of across it. A burst that misses the first man keeps traveling and finds the second, the third, the fourth. Fire like this has a name, enfilade, from an old French word for threading something end to end. It turns one lucky burst into a whole file of casualties, and it does something else just as valuable. It lets the gun sit behind a thick wall angled toward the enemy's main approach, with only a narrow firing slit facing sideways, hard to spot and harder to hit head-on. But a gun built to sweep sideways along a field is, by definition, bad at covering the ground directly in front of its own position. The firing slit barely turns that way. A handful of attackers who get close along that blind axis can walk right up to the position while it's staring at an angle across the field, unable to bring a single round to bear. Solving the frontal problem created a new one at the flank. The fix isn't a stronger gun. It's a second one placed on the opposite side of the position, aimed back across the same blind spot the first gun can't cover, and the first gun returns the favor, covering the approach to the second. Neither position defends itself anymore. Each one exists to protect its neighbor. Attack one and you expose your flank to the other. This is what military doctrine calls interlocking or mutually supporting fields of fire, and it's the real engine behind everything that follows. Add barbed wire and mines to the ground between the guns, not as a wall meant to stop anyone permanently, but as a filter, something that slows attackers down or funnels them along a predictable line for just long enough. Route that predictable line straight through the overlapping beaten zones of both guns, and every obstacle stops being a separate object and becomes part of one machine. This is no longer a collection of weapons, it's a system, where the ground itself, the wire, the mines, and every gun are all pointed at the same handful of square meters, and nothing that crosses that ground does so unnoticed or unshot at. This idea is a lot older than the machine gun. A plain medieval wall had almost the identical weakness as a lone frontal gun. Once an attacker reached its base, the defenders standing on top of it struggled to angle their weapons down far enough to hit anyone directly below. A dead zone hiding in plain sight. Towers solved it first, projecting out from the wall so archers inside could shoot sideways along the face of the neighboring section. Then cannons made tall medieval walls into an easy target, and European engineers, starting in Italy in the late 1400s and spreading across the continent through the 1500s, replaced them with lower, thicker walls broken into arrow-shaped bastions, the star-shaped forts you can still find on old maps. Each point of the star wasn't decoration. It let defenders fire along the base of the next bastion over, so an attacker climbing down into the ditch to escape fire from directly above ran straight into fire from the side instead. The engineer most associated with perfecting the design, Vauban, was actually working roughly 2 centuries after Italian builders had already worked out the basic geometry. He refined and standardized it. He didn't invent it. Which brings us back to that detail from Omaha Beach. Above the beach's draws, the narrow gaps in the bluffs that any vehicle needed to reach the interior, German engineers built strongpoints using exactly this logic. Take Widerstandsnest 62, overlooking what the Americans called Easy Red. Its guns, including 2 captured Czech field pieces and a scatter of machine guns, sat in casemates with a thick wall of concrete angled to face the sea, and a narrow firing slit turned sideways, aimed down the length of the beach instead of out at the water. A warship offshore was firing at a blind concrete face, not an open gun port. Meanwhile, the beach itself lay stretched out along the gun's most lethal axis, the long, thin, murderous shape of enfilade fire, running the length of the sand instead of across it. Further west, at the draw the Americans called Dog Green, 3 separate gun positions covered the same stretch of open beach from 3 different angles at once, each shielded from the sea by that same logic. Company A of the 116th Infantry landed almost directly in front of that crossfire at 6:30 in the morning, and within minutes lost more than 100 of roughly 150 men, an entire boatload, including its commanding officer, essentially erased before most of them had covered 30 yards of open sand. But a system built to sweep the beach had the same blind spot as a single gun turned sideways. It wasn't built to fight in every direction at once. It covered the sand and the draws beautifully and had almost nothing prepared for an attack from inland or from along the top of the bluffs it was sitting on. Small, mixed groups of American soldiers, men from different companies, some led by officers, some just following whoever was moving, found the gaps between strongpoints where the bluff line wasn't directly covered, cut wire, worked around minefields, and climbed. One lieutenant, John Spaulding, led a small section that reached the high ground above Easy Red by mid-morning, largely intact, then turned and hit a strongpoint from behind instead of the front it had been built to defend. Rangers further west found a similar gap, used grass fires for cover and smoke, and were on the bluff crest with only a handful of casualties. None of these strongpoints fell to a bigger gun or a braver frontal assault. They were unraveled from an angle their entire design had never accounted for. The lesson survives the change in equipment. Interlocking fields of fire are still standard doctrine today, taught for exactly the same reason a star fort was built the way it was. No single position should have to defend itself. Every position exists partly to protect the one next to it, and a gap between positions is worth more to an attacker than the positions themselves. Even the newest twist on this old idea comes from necessity. With drones watching almost every stretch of a modern front line in real time, defenders can no longer cluster obviously mutually supporting positions close together, because a drone operator can spot the pattern as easily as any historian reading an old map. Modern defensive belts are now reported stretching many kilometers deep, with positions spaced hundreds of meters apart instead of dozens, each one tied not directly to its neighbor, but to a separate fallback position further back. The same old principle of no point standing alone, just stretched out far enough that no single drone feed can see the whole shape of it at once. A machine gun pointed straight at the enemy is the obvious answer, and it's usually the wrong one. The gun that actually wins the position doesn't spend all its attention looking at the enemy. It spends it watching the ground its neighbor can't cover, and trusting that its neighbor is doing exactly the same for it.